This audiobook reveals the secrets of one of the most fascinating phenomena in the universe, black holes. From their theoretical discovery to their confirmation through observations, these mysterious objects have captured the imagination of scientists and curious minds alike. But what are black holes really, and why are they so important in the field of astrophysics? To understand the concept of a black hole, we must first think about gravity. Imagine gravity as a huge net that traps everything that comes too close. Black holes are the densest parts of this net, where gravity is so intense that nothing can escape, not even light. This is why they are called black holes. They are areas of space where light is lost, creating a visible void in the cosmos. The importance of black holes in astrophysics lies in what they teach us about the universe. They are natural laboratories that allow us to study the laws of physics under extreme conditions. By exploring their nature, scientists can unravel the mysteries of gravity, relativity, and the structure of space-time. Each black hole is a puzzle, and solving it can give us clues about how our universe was formed. The formation of a black hole is a fascinating process. Generally, it occurs when a massive star exhausts its nuclear fuel and collapses under its own gravity. This collapse causes the star to become an extremely dense point known as a singularity, surrounded by a boundary called the event horizon. This horizon is the limit where gravity becomes so strong that nothing can escape. So, if you get close to a black hole, be careful. Once you cross that boundary, there's no turning back. Black holes also have unique characteristics. In addition to their intense gravity, they possess what is known as spin. This means they rotate, creating fascinating effects in the surrounding space. The spin of a black hole even affects time, distorting it and curving the space around it. This phenomenon is so strange that it might seem straight out of a science fiction movie, but it is real and has profound implications for our understanding of the cosmos. As astronomers observe the universe, they have classified black holes into different types. There are stellar black holes, which are the result of the death of individual stars, and supermassive black holes, which are found at the centers of galaxies and can have millions or even billions of times the mass of the Sun. There are also primordial black holes, which may have formed in the early moments of the universe. Each type offers a window into different aspects of the formation and evolution of the cosmos. Black holes are not just passive objects. Their existence raises intriguing questions. What happens to the matter and energy that falls into them? Is it lost forever? This question leads us to discuss the information paradox, a dilemma that has intrigued physicists for decades. How we approach this mystery could change our understanding of physics itself. Within the framework of Einstein's general relativity, black holes are natural predictions. This theory revolutionized our way of conceiving gravity, showing us that it is not simply a force, but a curvature of space-time. Black holes are extreme examples of this curvature, where the laws of physics behave in unusual ways. The deeper we delve into their study, the more we encounter the boundaries of human knowledge. The fascination with black holes also extends to popular culture. From movies to books, these phenomena have been represented in various ways, capturing the imagination of generations. However, many of these representations are distorted and do not reflect scientific reality. It is essential to demystify these misconceptions to better understand what black holes truly are. As we continue to explore these cosmic mysteries, we must also consider their relationship with broader concepts, such as time and space. Some scientists have theorized that black holes could be gateways to other dimensions or even other universes, prompting us to reflect on our own existence and the place we occupy in the vast fabric of the cosmos. As we advance in our understanding of black holes, new questions also arise. What implications do they have for the future of space exploration? The possibility of extracting energy from their rotation has been a topic of debate. And although it may seem like a concept from a novel, scientists are seriously investigating these ideas. The exploration of black holes is an exciting journey, filled with discoveries and surprises. Each new finding brings us closer to unveiling the secrets of the universe, reminding us that, although there is much we do not know, human curiosity drives us to keep investigating. On this path, black holes are not just objects of study, but also a symbol of the endless quest for knowledge and understanding in a vast and mysterious universe. The fascination with black holes begins when we ask ourselves, how does one of these mysterious phenomena of the universe form? The answer lies in the life and death of stars. When a massive star exhausts its nuclear fuel, it can no longer hold itself against the force of gravity. At that moment, the star collapses in on itself, creating a gravitational force so intense that nothing, not even light, can escape its pull. This is the moment a black hole is born, a point in space where density is infinite and gravity becomes overwhelming. When thinking of a black hole, it's easy to imagine it as a monster that swallows everything in its path. But in reality, they are astronomical phenomena that can be better understood through some simple analogies. Imagine you are on a trampoline. If you place a basketball in the center, the surface will dip slightly. Now, if you put a golf ball next to the basketball, it will roll toward the center due to the slope created. Similarly, a black hole acts like a depression in the fabric of space-time, attracting everything that comes near it. Black holes have fascinating characteristics. One of their most intriguing traits is their mass, which can vary from a few times that of the Sun to millions or even billions of times more. This mass is concentrated in an infinitesimal point known as a singularity. But what does this mean for the space around them? The answer lies in the curvature of space-time. As you approach a black hole, gravity becomes more intense, distorting light and time itself. For a distant observer, time appears to slow down as someone approaches the event horizon, the boundary that marks the point of no return. The singularity, while fascinating, is a concept that challenges our understanding. Physicists have yet to describe what happens there. As the laws of physics as we know them seem to break down, it's like trying to understand what lies at the bottom of a bottomless pit. The more you look, the darker and more confusing it becomes. However, despite this lack of knowledge, black holes are essential for understanding the evolution of the universe. Without them, galaxies and stars would not have the same structure we observe today. Sometimes, the question arises, are there different types of black holes? The answer is yes. Black holes are primarily classified into three categories. First, there are stellar black holes which form from the collapse of massive stars. Then we have supermassive black holes which reside at the center of almost all galaxies, including our Milky Way. Lastly, there are primordial black holes which may have formed in the early moments after the Big Bang. Each type of black hole has its own characteristics and behaviors, but they all share the same essence. They are portals to the unknown. Imagine a stellar black hole as a small, voracious creature feeding on its surroundings, while a supermassive black hole is more like a titan that governs its galaxy, influencing star formation and the dynamics of entire galaxies. A common feature of all black holes is the event horizon, a limit that cannot be crossed. Beyond this point, gravity is so intense that not even light can escape. But what would happen if an object crossed that boundary? From the perspective of the object, time and space behave differently. To an external observer, the object would appear to slowly approach the event horizon, gradually fading away, as if it were freezing in time. The nature of black holes raises intriguing questions about space and time. Could there be something beyond the event horizon? The truth is that we do not know for certain. However, scientists continue to investigate and develop theories that could help us better understand these phenomena. Each discovery in this field opens the door to new questions and possibilities. Black holes are not only fascinating objects of study, but they also have important implications for our understanding of the universe. They teach us that there are limits to what we know and that there is much more to discover. Just as explorers of old ventured into the unknown, we too must look to the sky and ask what secrets black holes hold. In the end, human curiosity and the desire to understand the unknown drive us to keep exploring. Black holes are a reminder that in the vast universe, there is always more to learn and that the pursuit of knowledge is an endless adventure. Are we ready to continue exploring and discovering what lies beyond these mysterious phenomena? The answer lies in our desire to understand the cosmos and our place in it. Black holes are one of the most fascinating phenomena in the universe, and their classification can be summarized into three types: stellar black holes, supermassive black holes, and primordial black holes. But what do each of these categories really mean, and how do they form? Let's start with stellar black holes. Imagine a giant star, much larger than our sun. At the end of its life, this star exhausts its nuclear fuel and, in an impressive display of energy, explodes in a supernova. What remains is an extremely dense core that, if it has enough mass, collapses under its own gravity, creating a stellar black hole. This type of black hole can have between 3 and several tens of solar masses. But its influence on the surrounding space is immense. Moving on to supermassive black holes, the story becomes even more intriguing. They are found at the center of almost all galaxies, including our own, the Milky Way. These giants can have millions or even billions of times the mass of the Sun. How do they form? One theory suggests that they cluster from stellar black holes or develop from the matter that accumulates at the center of galaxies over billions of years. Imagine a magnet attracting everything around it, forming a massive ball that becomes a supermassive black hole. This not only affects the galaxy in which it resides, but also influences the formation of stars and other celestial bodies around it. Now, let's talk about primordial black holes, a concept that sparks the curiosity of many. These black holes would have formed in the early moments of the universe, just after the Big Bang. The theory suggests that fluctuations in the density of space-time could have created these small black holes, which can vary in size from very small to massive. Imagine the universe as a boiling broth where density bubbles arise and collapse, leaving behind these primordial black holes. Their existence could resolve many mysteries about dark matter and the evolution of the cosmos. We often wonder if these types of black holes interact with each other. The answer is yes, and in fascinating ways. Stellar black holes can merge to form a larger one, while supermassive black holes at the centers of galaxies can attract smaller black holes and consume them. What would happen if a stellar black hole approached a supermassive one? It would be an incredible cosmic spectacle where matter would be drawn in, and in the process, a tremendous amount of energy would be generated, visible even from millions of light years away. An intriguing question that arises is, why are black holes so important in astrophysics? The answer is that they help us better understand gravity, galaxy formation, and the evolution of the universe. By studying how they behave, we can learn more about the physical laws that govern the cosmos. Black holes act as natural laboratories where the theories of relativity and quantum mechanics intersect, challenging our conceptions of physics. Moreover, these phenomena are key in the search for answers about the ultimate fate of the universe. Black holes could be the last remnants of what were once stars, and their study could reveal much about how the universe expands and contracts. Could it be that, in a distant future, everything we know ends up in a black hole? The idea is both terrifying and fascinating. The relationship between black holes and energy also deserves mention. It has been proposed that the matter falling into a black hole is not lost, but can be transformed into energy through complex processes. This raises the possibility that in the future, we might find ways to harness that energy, turning a black hole into a source of inexhaustible resources. The mystery surrounding these black holes extends even to the nature of their existence. Despite being invisible, their influence is felt through the light of nearby stars that are affected by their gravity. This raises questions about how we can observe and study something we cannot see directly. The answer lies in observing their surroundings and detecting the gravitational waves they produce when merging. Each type of black hole has its own story and characteristics, making them a captivating topic for astrophysicists. From the small primordial black hole to the colossal supermassive black hole, each has a role to play in the grand theatre of the cosmos. And as we continue to explore this vast and mysterious expanse of space, black holes will remain one of the greatest enigmas, inviting us to discover more about our universe. In summary, black holes, with their variety of types and characteristics, are not only fascinating phenomena in themselves, but are also essential for understanding how the universe operates. They show us that there is much more than what we can see, and that despite their destructive nature, they can also be sources of energy and knowledge. Research on them is undoubtedly one of the most exciting fields of modern astrophysics. General relativity, formulated by Albert Einstein in 1915, not only changed our understanding of gravity, but also opened a window to a universe much more complex than we ever imagined. Have you ever wondered how it is possible for such a massive object as a star to curve the space-time around it? The answer to this question is fundamental to understanding what black holes are. In Einstein's theory, gravity is not simply a force that pulls objects together. Instead, gravity is the result of the curvature of space-time caused by the mass of an object. Imagine that space-time is like a large stretched canvas. If you place a heavy ball in the center, the canvas dips around it, creating a sort of depression. When you place a marble near this depression, the marble will move toward the heavy ball, not because there is a force pulling them, but because the canvas itself has been deformed. This is how gravity works according to general relativity. Now, what happens when a massive star runs out of fuel and collapses? This collapse can be so extreme that the star becomes a black hole, a region of space where the curvature of space-time is so intense that nothing, not even light, can escape. This raises a fascinating question. If light cannot escape, how do we know that black holes exist? The answer lies in the indirect evidence they provide us. For example, when a nearby star is in orbit around a black hole, we can observe how it moves. If the star behaves as if it is under the influence of a large invisible mass, we can deduce that a black hole is at play. But what about the event horizon? This is a crucial concept that derives from general relativity. The event horizon is like the boundary of a black hole, a limit beyond which nothing can return. Just as a river has a point where the current becomes so strong that nothing can return to the shore, the event horizon is the point of no return in space. Once something crosses this boundary, it is lost forever in the darkness of the black hole. General relativity also allows us to understand how time behaves near a black hole. Have you ever felt that time passes faster or slower at different moments in your life? The same occurs in the space-time around a black hole. As you approach the event horizon, time for an outside observer seems to slow down. This curious distortion of time leads us to another intriguing question. Could we travel through time if we managed to get close to a black hole? As we explore more about general relativity, we discover that there are also rotating black holes. These black holes not only attract matter toward them, but their rotation creates additional effects in the surrounding space-time. Think about how a whirlpool in water creates currents that drag everything nearby. the rotation of a black hole can pull the space-time around it, generating a region known as the ergosphere, where matter and energy can be dragged and, in theory, extracted. General relativity is not only fascinating in itself, but it also raises philosophical questions about the nature of the universe. If gravity can curve space and time, how does this affect our understanding of reality? The idea that space and time are flexible and can be manipulated leads us to think about the infinite possibilities that exist in the cosmos. In conclusion, Einstein's general relativity not only provides us with the tools to understand black holes, but also invites us to question our perception of reality. The way these massive, almost mystical objects affect space-time leads us to reflect on the very fabric of the universe. What else can physics reveal to us about the secrets hidden in the cosmos? As we delve deeper into these mysteries, we find ourselves on the frontier of the known and the unknown, where human curiosity continues to guide us toward new and exciting dimensions of knowledge. Rotating black holes are one of the most fascinating and enigmatic phenomena in the universe. But what makes them so special? The first thing to understand is that not all black holes are the same, just like in the world of planets and stars. There are different types of black holes, and those that rotate have unique characteristics that distinguish them from their static counterparts. Imagine a tornado. Its force and movement cause the air around it to be drawn in, creating a phenomenon completely different from a simple water reservoir. When a black hole spins, it behaves differently due to its rotation. This movement not only affects its own structure, but also the space surrounding it. Did you know that space-time, that fabric that makes up our universe, is uniquely warped around a rotating black hole? It's as if the black hole is dragging the fabric of the universe around it, creating a kind of cosmic vortex. This distortion is not merely a visual effect, it has real consequences on how matter and energy interact in its vicinity. In the case of rotating black holes, a fascinating concept known as the ergosphere is introduced. This region, which lies outside the event horizon, the point of no return, is a place where the rotation of the black hole affects everything nearby. In this zone, any object that approaches not only feels the powerful gravity of the black hole, but is also pulled along by its motion. The ergosphere is a place where time and space mix in surprising ways. It's like a boiling sea, where the waves are generated by the force of a whirlpool that never stops. But what happens if an object enters the ergosphere? Unlike static black holes, where the only option is to fall toward the event horizon, in the ergosphere, an object can gain energy and be propelled into space. This phenomenon is known as energy extraction from the ergosphere. Whoa! Imagine you are surfing a wave. If you manage to catch the right current, you can be propelled toward the shore instead of being dragged to the bottom. This is a simple analogy, but it illustrates how an object can harness the force of a rotating black hole to its advantage. The energy of the ergosphere is not just a theoretical concept. Scientists have proposed ways in which we could harness this energy in the future. If we could build technology capable of accessing this region, we might obtain energy in a way that today seems straight out of a science fiction movie. But what implications would this have for our civilization? We could envision practically inexhaustible energy sources that would radically change our way of living and exploring the universe. Reflecting on the rotational movement of a black hole, it is also important to mention how it affects gravity in its surroundings. The rotation not only distorts space, but can also influence the behavior of nearby matter. For example, stars and gas orbiting a rotating black hole may experience forces they would not encounter if they were around a non-rotating one. In this sense, a rotating black hole is like a kind of cosmic thief, which not only attracts matter, but also plays with the physical rules of its neighborhood. Einstein's general relativity is the key to understanding all these phenomena. This theory tells us that gravity is not just a force, but a curvature of space-time caused by mass. Therefore, a rotating black hole having an extremely dense mass and wild motion alters its environment in a way that is hard to imagine. The trajectories of other celestial bodies in its vicinity are affected, and the way light travels through that region is also distorted. So how can we visualize all this without getting lost in mathematical complexity? A good approach is to imagine a taut bedsheet. If you place a heavy ball in the center, the sheet will sag, creating a well. Now, if you start spinning that ball, you will see that the fabric of the sheet not only sags but also curves in a way that creates a swirling effect. This is a simple way to understand how the rotation of a black hole can influence the space around it. As we delve into the mysteries of rotating black holes, intriguing questions also arise. What would happen if a spacecraft could approach the ergosphere? Could humans in the not-so-distant future find ways to navigate these cosmic waters? Science fiction has explored these ideas, but the challenges are immense. However, human curiosity is unbreakable, and every answer we find about black holes leads us to new questions. In summary, rotating black holes are more than just simple astronomical phenomena. They are windows into a universe where the rules of physics are taken to the extreme. The way they spin, the energy they can generate, and the influence they have on their neighborhood are aspects that continue to challenge our understanding. As we keep exploring, we face an exciting future full of possibilities where the secrets of the cosmos could be closer than we imagine. The event horizon of a black hole is one of the most fascinating and perplexing concepts in astrophysics. But what does this phrase really mean? To understand it, we must first imagine an extreme scenario. Think of a place where gravity is so intense that nothing, not even light, can escape. This is the event horizon, the boundary that separates our reality from the unknown. The idea of a point of no return is unsettling. If you cross that line, there is no turning back. Now, what does it feel like to be near an event horizon? Gravity intensifies as you approach, and time, as we know it, begins to behave in strange ways. In fact, for an external observer, time appears to slow down for anything approaching that limit. Imagine watching a friend fall toward a black hole. As they near the event horizon, they seem to move slower and slower, almost as if they are frozen in time. That is a visual effect of extreme gravity. What would happen if you could cross the event horizon? In that instant, you would find yourself surrounded by a completely different world. The light trying to escape is distorted and twisted, creating a phenomenon known as gravitational lensing. This not only distorts light, but also alters your perception of space. The objects around you might appear closer than they actually are, and the direction in which you look could change drastically. Can you imagine the confusion of trying to navigate in a place where the rules of space and time are different? One of the most intriguing questions is, what is inside the event horizon? The truth is, we don't know. Physics as we understand it breaks down at that point. Some scientists suggest that the core of a black hole, known as a singularity, is where all the mass is concentrated in an infinitesimal space. Here, the laws of physics cease to function. It's as if you are in a place where the rules of the universe are rewritten. But why is the event horizon so important for astrophysicists? This concept helps us understand the limits of the universe and how the most powerful forces we know operate. By studying black holes and their event horizons, scientists can learn about the nature of gravity and time. Ultimately, this research leads us to deeper questions about existence itself. A surprising fact is that, although we cannot see the event horizon directly, we can observe its effect on the environment. For example, when a star close to a black hole is torn apart by its gravity, we can detect the radiation emitted by the matter swirling around it before falling into the black hole. This cosmic dance occurring near the event horizon is one of the ways we can study these mysteries. The relationship between the event horizon and light also raises fascinating questions. If light cannot escape, what happens to the information it carries? This dilemma becomes the center of what is known as the information paradox. It is a hotly debated topic in modern physics, where scientists are trying to reconcile quantum mechanics with general relativity. Does information really get lost in a black hole, or is there some way that this information can be retrieved? Furthermore, the idea of an event horizon also leads us to reflect on the concept of fate. If an object crosses that boundary, its fate is unavoidable, and this can lead us to think about our own lives and decisions. How many times do we find ourselves in situations where we feel we have crossed a limit from which we cannot return? This analogy can make us question how we handle our own experiences and choices. It is fascinating to think that the event horizon is not just a physical phenomenon, but also a window into philosophical debates. What does it really mean to cross a boundary? Does it imply an irreversible transformation? These are questions that resonate at the heart of human exploration, both in the context of the universe and in our daily lives. Black holes, and particularly their event horizons, also challenge us to imagine what the future of humanity might be like. If one day we could study these phenomena more deeply, or even travel close to them, what discoveries would we make? Perhaps we would learn to manipulate gravity in ways we currently consider impossible. The event horizon could become a symbol of unexplored opportunities on our path to knowledge. In the end, the event horizon remains an enigma, a reminder that there are aspects of the universe we still do not understand. By exploring these frontiers, we not only expand our knowledge of the cosmos, but also deepen our understanding of ourselves. Human curiosity is infinite, and just as light cannot escape a black hole, our questions will continue to flow, seeking answers beyond the unknown. So, as we look up at the sky and contemplate the mysteries of black holes, let us remember that the event horizon is more than a boundary. It is a symbol of humanity's endless quest to understand its place in the vast universe. The exploration continues, and each question we pose brings us a little closer to the truth hidden behind those dark and fascinating abysses. If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey. Did you know that black holes not only have an event horizon but also a fascinating region called the ergosphere? This place is truly unique and has surprising implications for physics and cosmology. The ergosphere is a region that lies just outside the event horizon of a rotating black hole. But what does this really mean? Imagine a vortex in water. When you swirl the water, objects near the surface are pulled along by the movement. In the ergosphere, something similar happens, but on a cosmic scale. The ergosphere extends from the event horizon to a considerable distance from the black hole. In this space, everything that passes is affected by the intense rotation of the black hole. The gravitational force is so strong that even light cannot escape its influence. However, unlike the event horizon where nothing can return, the ergosphere allows for some trajectories to be more flexible. If an object enters the ergosphere, it could exit with more energy than it had when it entered. Can you imagine that? It's as if an athlete could leave a racetrack with more speed than they had when they started. Now, why is the ergosphere important? This region is not just a theoretical phenomenon, it also has very real applications. Scientists have proposed that we could extract energy from the ergosphere. How would that work? If an object passed close to a rotating black hole, it could harness the energy from the black hole's rotational motion. This is similar to how windmills convert wind into energy. In this case, the wind is the rotation of the mass of the black hole. But what about creatures that venture too close? Objects that approach too near the event horizon have no escape. The extreme gravity traps them forever. However, in the ergosphere, there is an opportunity. The energy that can be generated is a concept that has intrigued scientists, as it raises the possibility that, in the future, we might use black holes as energy sources. But of course, this is still hypothetical and requires a very deep understanding of physics. The ergosphere also raises interesting questions about the nature of time and space. In this extreme environment, time behaves differently. The rotation of the black hole affects not only matter, but also how time is perceived in its vicinity. Could it be that in the ergosphere, time passes differently than how we experience it on Earth? These questions are fascinating and invite us to reflect on relativity and how space-time is warped in the presence of a black hole. Research on the ergosphere is ongoing, and scientists are trying to better understand how it works. There are theories suggesting that the ergosphere could be a place where unusual quantum phenomena could occur. Quantum physics and general relativity are two pillars of modern physics, and combining them in the context of black holes is a monumental challenge. But human curiosity always seeks answers. Imagine that in the future, technological advances allow us to explore the ergosphere of a black hole. What discoveries would we make? Perhaps we would find new types of particles or even forms of life that have adapted to these extreme conditions. The exploration of space has always challenged us to think beyond what we know, and the ergosphere is a perfect example of how nature can surprise us. The concept of the ergosphere also reminds us of how small we are in the vast universe. Often we worry about everyday problems, but when we look toward the cosmos, we realize that there are phenomena that transcend our understanding. The existence of the ergosphere and its relationship with black holes invites us to contemplate our place in the universe and the nature of reality itself. Rotating black holes and their ergospheres are a constant reminder that science still has much to discover. Each new answer opens the door to more questions. Curiosity is what drives scientists to keep exploring, and each small discovery can have a huge impact on our understanding of the universe. As we continue to investigate, it is exciting to think about how this knowledge could change our way of seeing the world. Science is advancing by leaps and bounds, and with emerging technologies, perhaps one day we will have the opportunity to explore the ergosphere of a black hole. The reality is that there is still much to learn, and the adventure is just beginning. The ergosphere could be just one of the many wonders awaiting us in the study of black holes. The possibility of extracting energy and exploring its mysteries makes this topic exciting, not only for scientists, but for all of us. Every time we look up at the night sky, let's remember that there is so much more than what we can see. Curiosity and the desire to know are what propel us forward, and black holes, with all their complexities, are a reminder of how vast and mysterious the universe we live in truly is. What is the mystery surrounding the rotation of a black hole? To understand it, we must first delve into a fascinating concept: gravity in space-time. When a black hole spins, it not only attracts matter towards itself, but its rotation also affects the fabric of space and time around it. It's as if, by spinning, it creates a whirlpool in the water, where everything that comes close is drawn towards its center. Imagine a carousel in an amusement park. When it spins, the horses on the edges are pushed outward due to centrifugal force, while those closer to the center are pulled inward. Similarly, a rotating black hole, known as a Kerr black hole, causes space-time to curve around it, creating a kind of gravitational wind that affects everything in its vicinity. What happens to objects that approach this gravitational whirlpool? When an object gets close to a rotating black hole, it experiences an attractive force that not only directs it towards the black hole, but is also influenced by the rotation. This means that as it approaches, it may be pushed to the side due to the force of the rotation. This phenomenon is known as frame dragging and is one of the most intriguing features of rotating black holes. The question that arises is, how does this dragging impact spacetime? The answer is that thanks to its rotation, the black hole can create a special region called the ergosphere. This zone is like an intermediate space where gravity is so intense that even light cannot escape. But unlike the event horizon, it is possible for matter to escape outward. It's as if you are in a fast-flowing river where the water rushes quickly in one direction, but you can find a small current that allows you to swim towards the shore. The ergosphere not only allows matter to escape, but also facilitates a fascinating phenomenon, the possibility of extracting energy. Can you imagine harnessing the energy of a black hole? In theory, if we could access this region, we could use the rotation of the black hole to generate energy, a concept that opens up a range of possibilities for space exploration and the future energy needs of humanity. But how could we do this? There are several theoretical ideas about how we could extract energy from the ergosphere. One proposed method involves sending probes or spacecraft into this region to capture the motion and energy generated by the rotation of the black hole. Although this sounds like science fiction, the principles behind it are rooted in Einstein's general relativity. The rotation of a black hole also has implications for how we perceive time. As we approach a rotating black hole, time slows down compared to the time we experience far from its influence. This is due to the intense curvature of space-time, which distorts our temporal perception. Essentially, a journey towards a black hole could mean that we would experience time very differently from those who remain at a safe distance. In this context, it is important to ask, what does this mean for our understanding of the universe? The interaction between the rotation of black holes and space-time suggests that gravity is not just a force that attracts, but can also be an agent that shapes realities. The way rotating black holes influence their surroundings invites us to reflect on the very nature of time and space. Moreover, research on rotating black holes offers us a window into understanding broader phenomena in the universe, such as galaxy formation and the evolution of cosmic structures. By studying how these cosmic titans interact with their environment, we can gain insights into the history of the universe and its future. On the other hand, we cannot forget that the existence of rotating black holes also raises questions about the nature of matter and energy. These extreme objects challenge our notions of what is possible in physics, and every discovery we make about them brings us one step closer to unraveling the secrets of the cosmos. Finally, the fascination these phenomena generate cannot be underestimated. The idea of rotating black holes is not only a topic of study in astrophysics, but has also sparked the imagination of writers, filmmakers, and dreamers over the years. These cosmic giants remind us that although we are anchored to our planet, the universe is full of mysteries yet to be discovered. So as we continue to explore the rotation of black holes, let us remember that every question we ask not only opens new doors in science, but also fuels our curiosity and our quest for knowledge in this vast and amazing universe. What is vacuum energy and how is it related to black holes? To understand this, we first need to explore a fascinating concept. The vacuum is not simply the absence of matter. In fact, in physics, the vacuum is full of activity. Imagine an ocean of possibilities where virtual particles continuously arise and disappear, like bubbles that appear and fade on the surface of water. This phenomenon is what is known as vacuum energy. Now, what does this mean for black holes? These cosmic objects, which are incredibly dense and possess gravity so strong that nothing can escape their pull, create a peculiar effect in the surrounding space. Just like a large magnet that attracts everything around it, black holes influence vacuum energy. This raises an intriguing question. Could we use this energy for something more than just understanding the universe? The idea of extracting energy from the vacuum may sound like science fiction, but scientists have theorized about methods to do so. Can you imagine being able to obtain energy from a black hole? It would be like having an inexhaustible source of energy. Similar to how plants convert sunlight into energy through photosynthesis. However, it is important to note that this theoretical process is not straightforward and is still fraught with challenges. A key concept in this discussion is the ergosphere, a region that lies beyond the event horizon of a black hole. In this zone, space-time is distorted by the rotation of the black hole, creating an environment where energy could potentially be extracted. How does this work? Imagine you are on a skating rink, but instead of gliding over ice, you find yourself on a rapidly spinning surface. You could harness that rotational energy to propel yourself forward. But what are the implications of extracting energy from a black hole? In theory, we could use this energy to power spacecraft, drive advanced technologies, or even provide energy to colonies on other planets. Imagine a future where our cities are powered by energy coming from a distant black hole. However, this leads us to a fundamental question. Would it be safe? Black holes are extremely dangerous phenomena, and any attempt to interact with them would require a carefully planned approach. Scientists have proposed various theories on how we might extract this energy. One of them is the concept of the Penrose machine, which suggests that we could capture some of the energy moving through the ergosphere. Isn't it fascinating to think that even though we are millions of light years away from a black hole, we could find ways to harness its energy? However, despite the possibilities, there is a significant challenge. Current technology is nowhere near capable of achieving these feats. The idea of traveling to a black hole or building a machine that can extract energy from it is, at this moment, a distant dream. But science is always advancing, and what seems impossible today could become reality in the future. As we reflect on vacuum energy and its relationship with black holes, it is also important to consider the philosophical implications of this research. What does it mean for our understanding of the universe? Could our ability to manipulate vacuum energy change not only our technology but also our perception of reality? Perhaps at some point we will discover that the vacuum is not just a space devoid of matter, but a vital resource that can connect aspects of physics, technology, and our very existence. The debate about vacuum energy and black holes also takes us to another level of exploration. As we try to understand how the universe works, we realize that there are more questions than answers. Are we prepared to deal with the possibilities that this energy could bring? Are we ready to face the ethical dilemmas that arise from manipulating such powerful forces? In conclusion, vacuum energy presents itself as an exciting area of research full of potential. As scientists continue to explore the mysteries of black holes and their relationship with the vacuum, we can imagine a future where the energy of the universe is accessible to all. The quest for this energy connects us with the depths of our curiosity and desire to understand the cosmos, opening new doors to discoveries yet to come. The exploration of these concepts invites us to dream of a future where science and imagination intertwine, and where the stars are not just distant objects but sources of energy and knowledge. Have you ever imagined what it would be like to extract energy from a black hole? The idea may seem straight out of a science fiction movie, but in reality it is a topic that has intrigued scientists and thinkers for decades. Black holes, those mysterious and fascinating objects of the universe, are not only known for their incredible gravity, but also for their potential to be an almost inexhaustible source of energy. How is this possible? To understand it, it is essential first to explore the concept of the ergosphere, a region that surrounds rotating black holes. Imagine a huge whirlpool in the ocean. As you get closer, you feel how it pulls you in, even if you haven't crossed the point of no return. In the case of a black hole, the ergosphere is that area which, although not a point of no return, is dominated by the rotation of the black hole. Here, Space-time behaves strangely, allowing objects within this region to extract energy from the rotation of the black hole. But how does this work exactly? When a black hole spins, it drags along the space around it. This phenomenon is known as frame dragging. Imagine the black hole as a large spinning disk. As you approach, you not only feel the wind from its rotation, but you can also harness that energy by introducing an object, such as a spacecraft, into the ergosphere. It may be possible for it to take advantage of the black hole's motion to obtain energy, but this is not as simple as it seems. What kind of technology would we need to achieve this? One of the most intriguing proposals is the use of what is called an energy extraction probe. This hypothetical device could be designed to enter the ergosphere and use its rotation to accelerate its own speed. Think of a skater spinning on an ice rink. By stretching their arms out, they can increase their rotational speed. Similarly, a probe could use the motion of the black hole to gain energy and ultimately send that energy back to Earth. But could we really build something like this in the future? The idea of harnessing energy from black holes is not just a theoretical concept. Scientists have begun to explore how this energy could be used in space exploration. Imagine a mission to a distant planet where energy is obtained from a black hole instead of relying on the limited fuel reserves we have on Earth. This vision could change how we conceive of interplanetary travel. But here comes another intriguing question. Would it be safe to get so close to a black hole? The danger is undeniable. Approaching a black hole involves enormous risks, from the intense gravity that can tear apart any spacecraft to the radiation generated in the process. However, human curiosity has always found ways to confront the unknown. If we manage to develop the right technology to protect astronauts and spacecraft, we could open a new era in space exploration. In this context, vacuum energy also plays a fundamental role. This energy, found in empty space, is an unexplored source that could be combined with the energy extracted from the ergosphere to create an almost limitless energy system. What if we could combine the energy from black holes with vacuum energy to solve Earth's energy problems? The possibility of using black holes as energy sources raises profound questions about our understanding of the universe. Are we destined to be mere observers of these cosmic phenomena, or can we become their allies in the quest for a new energy era? Exploring these ideas not only challenges our technological capabilities, but also our perception of what is possible in the cosmos. As scientists continue to investigate these possibilities, it is fascinating to imagine how one day we could have space stations powered by the energy of a black hole. Science fiction could become a reality if we manage to understand and utilize these mysteries of the universe. But again, the question persists: will we be able to handle such power without unleashing forces we cannot control? Ultimately, extracting energy from the ergosphere is not just a technical challenge, but also an ethical issue. Is it right to harness energy from a black hole, or should we leave these phenomena alone? The search for answers to these questions will lead us to a future where human curiosity and responsibility intertwine in the exploration of the cosmos. Ultimately, the energy from black holes could not only define our ability to travel through space, but also our understanding of ourselves and our place in the universe. The information paradox is one of the most intriguing mysteries of modern physics. What happens to the information that falls into a black hole? This enigma has challenged scientists and philosophers for decades, generating passionate debates that may seem straight out of a science fiction novel, but are deeply rooted in the reality of the universe. To understand this paradox, it is first necessary to become familiar with the concept of information in the context of physics. Imagine that information is like a collection of books in a library. Each book contains data about the universe, events, states of particles, the history of stars, and even about ourselves. When a black hole forms, it is as if a part of that library is closed off and thrown into a dark corner where no one can access it. The question that arises is, What happens to those books? Do they get lost forever, or can they somehow be recovered? Quantum theory, which governs the behavior of particles at the microscopic level, holds that information is never lost. However, general relativity, which describes gravity and the structure of space-time, suggests that anything crossing the event horizon of a black hole becomes trapped inside. This contradiction has led to a crisis of understanding between the two pillars of modern physics, creating what is known as the information paradox. For years, some scientists argued that information is destroyed when it falls into a black hole, which would violate one of the fundamental laws of physics. This idea is so unsettling that it has led figures like Stephen Hawking to rethink their understanding of black holes. Hawking, famous for his work in cosmology, proposed that through a phenomenon known as Hawking radiation, black holes could emit particles and, in a way, allow some information to escape. But does this really resolve the mystery of information loss? Another approach suggests that information is not lost, but transformed. When an object crosses the event horizon, its information could be encoded in the radiation emitted by the black hole. Imagine that instead of destroying the books, the black hole converts them into a kind of code that radiates back into the universe. However, this code would be extremely difficult to decipher, so while the information might be there, retrieving it would be like trying to read a book in a language we do not know. Meanwhile, some physicists have suggested that information could be stored on the surface of the black hole in what is known as the holographic hypothesis. This idea posits that all the information falling into a black hole could be contained on its event horizon, as if the black hole were a projection of a more complex reality. This leads us to a fascinating reflection. Could black holes be carriers of information about everything they have devoured? The debate over the information paradox also raises profound philosophical questions about the nature of reality and our understanding of time and space. Is time linear, or could it be that upon falling into a black hole, information is reorganized in such a way that it allows for a form of time travel? Although we do not yet have definitive answers, these questions compel us to consider what we truly understand about the universe. At this point, it is essential to recognize that science advances through the exploration of the unknown. The information paradox may seem like a riddle without a solution, but it also represents an opportunity to expand our horizons. As scientists continue to investigate, the possibility of new discoveries is exciting. Perhaps the future will bring us a new theory that unifies relativity and quantum mechanics, thus revealing the key to solving this enigma. As we reflect on the information paradox, it is important to remember that each discovery brings us one step closer to understanding the complexity of the universe. While the idea of losing information in a black hole may seem frightening, it is also a reminder that science is in constant evolution, always seeking answers to the deepest questions. Ultimately, the information paradox invites us to contemplate our own existence. If information is preserved in some way, what does that mean for us as human beings? Are we connected in some way to the vast cosmos and the mysteries that remain to be unraveled? The wonder of the universe is full of enigmas, and the information paradox is just one of many that await us on the path to deeper understanding. Wormholes are one of the most fascinating ideas in the realm of astrophysics and science fiction. What if I told you that there are hidden routes in space that could connect us to different points in the universe? Imagine a tunnel that traverses the fabric of space and time, allowing us to travel from one place to another in the blink of an eye. That is the promise offered by wormholes, also known as Einstein-Rosen bridges, in honor of the scientists who proposed them. To better understand this concept, let's think about a map. If you want to go from one city to another, you would normally follow a path that takes you from one point to another. But what if you could fold that map and make both points touch? That's how wormholes work. They create a sort of shortcut in the vast space-time. But but are they really viable? The first dilemma we encounter is that although wormholes are mathematical solutions to the equations of general relativity, there is no concrete evidence that they exist in nature. Some scientists believe they could be unstable, meaning they would collapse before anyone could traverse them. However, there are those who think that, with the right technology, we could stabilize them. Imagine a future where humans can travel through these tunnels and explore distant places in a matter of seconds. The theory of wormholes also raises intriguing questions about time. Is it possible that traveling through one of these tunnels could allow us to go back in time? The idea that we could visit historical moments or even change the course of history is undoubtedly a concept that has captivated the imagination of many. However, this also brings paradoxes, such as the famous grandfather paradox, which raises the question of what would happen if you traveled to the past and altered key events. In this context, it is interesting to remember that black holes and wormholes are closely related. Some theorists suggest that a black hole could be the entrance to a wormhole, while the other end could be in a completely different place in the universe, or even in another universe. This raises the possibility that by entering a black hole, we could emerge in a completely different place and time. But do we really want to risk crossing that boundary? Wormholes have also been a recurring theme in science fiction. Movies and books have explored their possibilities, offering both optimistic and terrifying visions of what it might mean to travel through them. In many of these stories, protagonists face moral and ethical dilemmas about the use of this technology. Should we explore the past? Or is it better to leave it untouched? The science behind wormholes is complex and often treads into the realm of speculation. Some scientists have proposed that we might need exotic matter, a form of matter that has unusual properties, to stabilize a wormhole. But what exactly is exotic matter? Could it be that we have yet to discover it, or perhaps we will never find it? Another fascinating aspect is how wormholes might interact with the energy of the vacuum. The vacuum in space is not really empty. Within it, quantum fluctuations occur that could play a role in the creation or stabilization of wormholes. This opens the door to a world of possibilities where quantum physics and relativity meet and intertwine. The idea of wormholes also leads us to reflect on the nature of time itself. Is time a straight line, or could it be more like a surface that we can manipulate? If wormholes are possible, that suggests that time might not be as linear as we think, raising profound philosophical questions about our existence and our place in the universe. In summary, wormholes are an area of exploration that combines science, philosophy, and imagination. Although we still do not have definitive answers about their existence or viability, the mere possibility that they exist invites us to dream about the future of space exploration and time travel. As science advances, it never ceases to amaze us, and what seems impossible today could be a reality tomorrow. So, every time we look up at the starry sky, let's think of all the wonders that still await us, from the mysterious black holes to the intriguing doors that could lead us to other corners of the universe. The exploration of wormholes is not just an adventure in space, but also a journey in our understanding of time, matter, and perhaps reality itself. Who knows what discoveries the future holds for us? Have you ever thought about the possibility that the energy emanating from black holes could be used for our benefit? That idea may sound like something out of a science fiction movie, but currently, scientists are exploring concepts that could turn these mysterious cosmic objects into sources of energy. We could imagine black holes as gigantic cosmic vacuums. Around them, in their environment, there is an immense amount of matter and energy. For a long time, it was thought that everything falling into a black hole was lost forever. However, recent research suggests that it is not that simple. What if we could harness the energy from these rotating objects? The concept of extracting energy from a black hole is intriguing, and in fact, there are theories that support it. One of the most fascinating methods for obtaining energy from a black hole is through the ergosphere. a region located beyond the event horizon. The ergosphere is an area where space-time is affected by the rotation of the black hole. In this space, something unusual happens. As an object approaches the black hole, it can gain energy by taking advantage of its rotation. It's as if you could surf on the wave of gravity, allowing an object to exit the ergosphere with more energy than it had when it entered. Imagine you have a bowling ball. If you throw it towards a rotating black hole, the ball can be accelerated by the rotational movement. The result is that upon exiting, the ball could have more energy than it had initially. This concept, known as the Penrose effect, is based on the idea that energy can be extracted from the black hole through its rotation. But could we really apply this in practice? In theory, yes, but we are still far from achieving it. An interesting aspect of this quest for energy is how it could be utilized. The energy extracted from a black hole could be enough to power an entire city or even propel spacecraft on intergalactic journeys. Imagine that instead of relying on fossil fuels or solar energy, your home could obtain its energy from a black hole, a distant object in the universe. It sounds like a dream, but the physics behind this idea invites us to explore possibilities that go beyond our current understanding. However, it's not all that simple. The technology needed to access a black hole and extract energy from it is still in its infancy. As we continue to investigate, questions arise. How much energy could we really obtain? Would it be safe to approach a black hole to extract energy? And most importantly, could this energy be controlled and used sustainably? Extracting energy from black holes is not just a theoretical exercise. It also leads us to reflect on our relationship with the universe. If we ever managed to do it, we would be opening a door to new frontiers in space exploration and understanding of physics. But what implications would this have for humanity? Could it change the way we view our existence and our place in the cosmos? As scientists continue to research, it is essential to consider the potential risks and benefits. The energy from black holes could be a solution to the energy crisis we face. But it also raises ethical dilemmas. Are we prepared to handle such a powerful energy source? Could we fall into the temptation to abuse it? The idea of extracting energy from black holes invites us to dream, to look beyond what we know, and to consider what might be just around the corner in the future of science. Each discovery in this field brings us closer to unraveling the secrets of the universe and better understanding our place within it. The journey towards understanding and potentially utilizing the energy of black holes is just the beginning. The questions we ask today may hold the key to opening new doors in science and technology. What seemed like a science fiction concept could become a reality in the coming decades, and it is exciting to think about the possibilities that await us. So the next time you look up at the sky and see the stars, remember that somewhere in the universe, black holes might not only be the end of matter, but also the key to a future filled with unlimited energy. Science is advancing by leaps and bounds, and who knows what discoveries await us on the horizon. Have you ever looked up at the starry sky and felt small in the face of the vastness of the universe? That feeling becomes even more intense when talking about black holes, those mysterious phenomena that seem to challenge the laws of physics. But how do we know they really exist? The answer is not simple. It is the result of years of observations and research that have revealed much about these cosmic giants. First, it is essential to understand that black holes are not directly visible. They do not shine or emit light like stars. Instead, astronomers detect them through their effects on the surrounding environment. How do they do this? Imagine you are in a park and see the leaves of the trees moving, but there is no wind. If you look closer, you might find a hidden fan. This is how scientists discover black holes. They observe how the matter around them behaves strangely, as if it is trapped in a powerful gravitational pull. One of the first major breakthroughs in detecting black holes came in 1994 when a stellar system in the constellation Lyra was observed. In this system, a companion star appeared to orbit something invisible. Scientists calculated that the mass of this hidden object was at least 3 times greater than that of the Sun. This discovery was a significant step, as it provided tangible evidence of the existence of stellar black holes, those that form after the death of massive stars. But what about supermassive black holes? They are found at the center of most galaxies, including our Milky Way. There is evidence that these gigantic black holes can have millions or even billions of times the mass of the Sun. They were discovered through the study of the light from the stars that orbit around them. When these stars follow a fast orbit, scientists can deduce the mass of the object that attracts them, which turns out to be a supermassive black hole. In 2016, a historic event took place. The first detection of gravitational waves, a phenomenon predicted by Einstein's theory. These waves were generated when 2 black holes merged. This discovery was not only a milestone in astrophysics, but also provided a new way to study black holes. Gravitational waves are like ripples in a pond when you throw a stone. They propagate through space and can reveal information about distant cosmic events. In 2018, the Event Horizon Telescope, an international project, made a significant leap by achieving the first image of the event horizon of a supermassive black hole in the galaxy M87. This image was a monumental achievement, like capturing the shadow of a cosmic giant. It was accomplished using a technique called very long baseline interferometry, which combines data from telescopes around the world. This joint effort demonstrated that science can unite nations in the pursuit of knowledge. Scientists have also taken advantage of the X-ray radiation emitted by the material swirling around black holes. When matter falls toward a black hole, it heats up to extreme temperatures and emits light, which can be detected with specialized telescopes. Thus, black holes become sources of light, albeit indirect, allowing us to study their properties. Of course, it hasn't all been easy. Throughout history, black holes have been the subject of controversy and debate. For a long time, some scientists resisted accepting their existence, as they seemed to challenge our notions of physics. However, as more evidence accumulated, the scientific community began to accept that these phenomena were an essential part of the cosmos. Advances in technology have also allowed astronomers to observe black holes at different wavelengths, from radio to gamma rays. Each wavelength reveals different aspects of these cosmic mysteries and helps us build a more complete map of their nature. Thus, research on black holes continues to evolve, merging theory with observation. A fascinating aspect of black hole research is international collaboration. Scientists from around the world work together on projects that cross borders and disciplines. This cooperation is a testament to the human spirit and our curiosity to understand the unknown. The more we learn about black holes, the more we realize that each discovery raises new questions. In recent years, we have seen an increase in the number of telescopes and space missions dedicated to the study of black holes. From the Chandra satellite, which observes X-rays, to the future LISA Space Observatory, which will measure gravitational waves, the field is constantly expanding. Each of these instruments is like a magnifying glass that allows us to see closer and better understand these phenomena that, at their core, are both fascinating and terrifying. In conclusion, research on black holes has come a long way since its early theories. Today, thanks to observation and international collaboration, we have begun to unravel the secrets that these cosmic giants guard so jealously. As we move forward, the path of discovery remains exciting, and each new finding brings us closer to understanding one of the most intriguing phenomena in the universe. Black holes show us that there is still much to learn and explore in the vast cosmos that surrounds us. Black holes have captured the imagination of writers and filmmakers for decades. But why are they so fascinating? The answer lies in their mystery and the way they challenge our notions about the universe. From science fiction to documentaries, these cosmic phenomena have been represented in multiple ways. In movies like Interstellar, they are shown as portals to other worlds, while in books like Frank Herbert's The Black Hole, the philosophical implications of their existence are explored. But do we really know what they are and how they work? In popular culture, black holes are often portrayed as voracious monsters devouring everything around them. This image, while striking, is somewhat distorted. In reality, a black hole is not a monster moving through space, but rather a point of no return where gravity is so intense that nothing, not even light, can escape. This concept has been explored in numerous works, ranging from literature to video games, where black holes are used as narrative tools that allow characters to explore the unknown. One of the most intriguing questions that arises is, could we really travel through a black hole? In many narratives, this concept is enthusiastically explored, suggesting that we could use these phenomena to travel to other points in space or even to other moments in time. However, the reality is much more complex. While science fiction invites us to dream, science tells us that survival when crossing a black hole is unlikely, leading us to wonder, is it possible that fiction helps us better understand science? Some movies have tackled the topic of the information paradox in black holes. In Interstellar, for example, it is mentioned how information could be preserved even after crossing the event horizon. This idea has captured the attention of many, raising questions about the nature of reality. What happens to the information that falls into a black hole? Is it lost forever, or in some way can it be recovered? This dilemma has inspired both scientists and writers to explore the intersection between science and philosophy. Television series have also addressed the theme of black holes. In The Big Bang Theory, and they are referenced in a humorous context, demonstrating that these complex concepts can be accessible and entertaining. Through comedy, science can be demystified and made more understandable for the public. This approach helps more people become interested in astrophysics, which is essential in a world where scientific education is more important than ever. The representation of black holes in visual art is also striking. From paintings to animations, their singular shape and mystery have inspired many artists to capture the essence of these phenomena. Images of a black hole with its bright accretion disk may seem dreamlike, but they also reflect the reality of what exists in the cosmos. These artistic representations are not only visually appealing, but also help educate the public about the true nature of black holes. Video games have found in black holes an inexhaustible source of inspiration. In titles like No Man's Sky, we are presented with the opportunity to explore distant galaxies, and along the way we encounter black holes that act as portals. This is not only exciting for players, but also introduces scientific concepts in a fun way. By interacting with these phenomena, players can develop a more intuitive understanding of how black holes function in the universe. In the realm of literature, authors like Stephen Hawking have popularized the science of black holes through their books. With an accessible style, they have managed to bring complex concepts to a wider audience. This demonstrates that science and literature are not necessarily opposed, but can coexist and enrich each other. Curiosity about the cosmos can be fueled by both rigorous science and creative narrative. An interesting aspect is how black holes have come to symbolize the unknown. In many stories, they represent our fears and anxieties about what lies beyond our understanding. This metaphor is used to explore themes such as loss, sacrifice, and the search for answers. Thus, black holes transcend their physical nature and become a narrative tool that invites reflection. Conferences and documentaries about black holes have also proliferated in recent years. These productions not only inform but also inspire new generations of scientists and explorers. By showcasing the beauty and mystery of the universe, they manage to capture the attention of people who might otherwise not be interested in science. The combination of impactful visuals and clear explanations allows complex concepts to be accessible. Finally, it is important to emphasize that while black holes are fascinating phenomena, they also serve as a reminder of the humility we must have in the face of the vast universe. They teach us that there is much more to discover and that our knowledge is just the tip of the iceberg. The representations of these cosmic giants in popular culture not only entertain but also motivate us to continue exploring and learning. The next time you watch a movie or read a book that mentions black holes, remember that beyond fiction, there is a real world of science and mystery waiting to be explored. Each story, each representation, invites us to delve a little deeper into the understanding of these enigmatic phenomena and perhaps in the search for answers about the universe we live in. Thus, black holes become a bridge between science and imagination, uniting people in their shared curiosity for the unknown. In the vast darkness of the universe, black holes are like mysterious giants calling us to explore the unknown. But how are these intriguing phenomena studied? The answer lies in a series of missions and telescopes dedicated to unraveling their secrets. Imagine a group of scientists and astronomers equipped with cutting-edge technology working tirelessly to observe these cosmic titans. How do they manage to do it? One of the most powerful tools in this quest is the Hubble Space Telescope. Since its launch, it has provided stunning images and data about black holes, allowing researchers to see beyond what our eyes can capture. Did you know that Hubble can observe the light emitted by material falling into a black hole? This light, which heats up and shines brightly, offers us clues about the mass and behavior of these celestial monsters. However, Hubble is not alone in this mission. The Event Horizon Telescope, a revolutionary project, has been specifically designed to capture the shadow of a black hole. In 2018, it achieved an astonishing feat. It captured the first image of a black hole located at the center of the galaxy M87. Can you imagine the excitement of the scientists when they saw that shadow? It was a historic moment that validated many theories about the nature of these celestial bodies. But what about the future? The next generation of telescopes promises to take our understanding even further. Projects like the James Webb Space Telescope are designed to observe the universe in wavelengths we have never explored before. With its ability to see through dust and gas, it could reveal crucial information about the formation and evolution of black holes. On Earth, scientists are also experimenting with gravitational wave detectors, such as LIGO and Virgo. These facilities have made it possible to hear the waves created by the merger of black holes. Have you ever thought about what those waves mean? They are echoes of the universe telling us stories about cataclysmic collisions and the dance of these giants in space. Each detection is a new chapter in our understanding of the cosmos. Additionally, there are planned missions aimed at exploring the surroundings of black holes. For example, the European mission Euclid, set to launch in the near future, aims to map the structure of the universe and better understand dark matter. In doing so, it will also provide clues about the influence of black holes on galaxy formation. Meanwhile, astrophysicists are using computer simulations to model the behavior of black holes and their effects on space-time. These simulations are like creating a miniature universe where they can experiment and visualize how these colossi interact with their environment. What if I told you that some of these simulations are so realistic that they can even predict how light would appear around a black hole? International collaboration also plays a crucial role in black hole research. Scientists from different countries come together to share data and resources, creating a global network of knowledge. This synergy allows for greater understanding and faster progress in our research. Isn't it fascinating to think that somewhere in the world there is a group of people working together to solve one of the greatest mysteries of the universe? Something that is often overlooked is the importance of education and scientific outreach. As more people become interested in astrophysics, the demand for information about black holes and other wonders of the cosmos grows. YouTube channels, podcasts, and documentaries are helping to democratize knowledge, making science accessible to everyone. This collective curiosity is a catalyst for future research. As we advance in the study of black holes, we are not only learning about these enigmatic objects, but also about ourselves. Each discovery has the potential to change our understanding of the universe and our place in it. Who knows what new horizons will open up in the next decade? In summary, the quest for knowledge about black holes is not just a matter of science. It is a human adventure. From telescopes that gaze at the stars to missions that challenge the limits of our understanding, every step we take brings us a little closer to unveiling the secrets of these cosmic giants. Curiosity and imagination are our best tools in this exploration, and the future promises to be as exciting as the past. So, as we continue to look to the sky, let us remember that each black hole we study is a door to the unknown. With each mission, with each telescope, we are writing a new story about the universe. What new mysteries will scientists uncover in their quest? The answer lies beyond our horizon, waiting to be revealed. Did you know that many of the myths surrounding black holes come from movies and science fiction books? The fascination with these mysteries of the universe has led to the creation of stories that, while exciting, often distort reality. Have you ever been swayed by the idea that black holes are cosmic vacuums that swallow everything in their path? While they do have immense gravitational power, they are not as devouring as one might think. A common misconception is that everything that approaches a black hole is inevitably absorbed. Imagine you are in a lake and see a whirlpool. If you stay at a certain distance, it won't drag you in. The same is true for black holes. If an object is far enough away, it can orbit around them without being swallowed. Gravity acts like a magnet, but there is also a point where that attraction becomes irresistible, the event horizon. On the other hand, it is said that black holes are doors to other universes. This idea has captured the imagination of many, suggesting that by crossing the event horizon you could emerge somewhere else or even in another time. However, current science does not support this notion. Once you cross that boundary, reality becomes extremely strange and, in a sense, dangerous. Understanding what happens inside a black hole remains a mystery. Moreover, the belief that black holes are necessarily dark and invisible has become popular. It is true that they do not emit light, but that does not mean they are completely undetectable. Astronomers have developed clever methods to observe their influence on the stars and gas surrounding them. Just as a lighthouse in the dark can be seen by its light, black holes reveal their presence through their effects on the space around them. One of the most intriguing myths is that black holes could be portals for time travel. Although this idea has been explored in numerous science fiction stories, the reality is much more complex. The physics of black holes, as we understand it today, suggests that while there might be solutions to Einstein's equations that allow for time travel, there is no concrete evidence that these phenomena are accessible or functional in the universe we know. And let's talk about the notion that black holes are the absolute end. Is there nothing we can do? The reality is that instead of being the end, black holes could be the beginning of something new. The matter that falls into them does not completely disappear. There are theories suggesting that it could emerge in the form of radiation through complex processes. So, in a way, black holes could be transformers, not just destroyers. Another interesting myth is the idea that all black holes are enormous, while supermassive black holes are true giants at the heart of galaxies. There are also stellar black holes, which are much smaller. These form from the collapse of massive stars and are more common than we might think. In other words, the universe is full of black holes, both large and small, and each has its own story. The idea of black holes as malevolent entities is also a misconception. In the vast cosmic theatre, black holes play a crucial role in the evolution of the universe. They act as engines of galaxy formation and are essential for the balance of matter and energy. So instead of being villains, we might consider them important players in the cosmic story. Regarding the notion that black holes are unreachable and that we will never be able to study them, it is essential to understand that science is advancing by leaps and bounds. With advanced telescopes and new technologies, humanity is getting closer to understanding these mysteries. Each discovery brings us closer to demystifying black holes and unraveling their secrets. And what about the idea that black holes are eternal? While they can last a very long time, they can eventually evaporate through a process known as Hawking radiation. This means that on an extremely long timescale, even black holes can disappear. This contradicts the notion that they are indestructible and adds another layer of complexity to their nature. Finally, it is important to mention that black holes are not just isolated cosmic phenomena. Their study leads us to better understand fundamental physics, relativity, and the forces that shape our universe. So far from being merely objects of curiosity, black holes are key pieces in the puzzle of the cosmos. Demystifying black holes allows us to better appreciate the complexity of the universe. Each myth offers us an opportunity to explore more deeply and discover the reality that lies behind these astonishing phenomena. At the end of the day, black holes are both an intellectual challenge and a window into the wonders of the cosmos, reminding us that while there is much we do not understand, the journey of discovery is just beginning. The physics behind black holes is a fascinating maze of concepts that invites us to explore the limits of our understanding of the universe. What happens when a massive star exhausts its fuel? The answer lies in a struggle between gravity and internal pressure. When there is no longer enough energy to hold against gravitational attraction, the star collapses in on itself, creating a black hole. But why is this collapse so special, and what does it really mean? Imagine a bowling ball on a trampoline. If we place the ball in the center, the trampoline sinks. The heavier the ball, the more the surface deforms. Now, if the ball is a massive star, when it runs out of energy, the trampoline sinks so much that it creates a hole. This hole is what we know as a black hole, a point in space where gravity is so intense that nothing can escape, not even light. Isn't it amazing to think that light, the very light that allows us to see the world, cannot escape from a black hole? Einstein's theory of relativity helps us understand these extreme phenomena. In his famous equation E equals mc squared, he tells us that mass and energy are interchangeable. When a star collapses, its mass converts into an incredibly powerful gravitational energy. This energy distorts the space and time around it. But what does this mean in terms of our perception of reality? Let's visualize a clock. When it is near a black hole, time does not pass in the same way it does on Earth. If you could observe someone falling into a black hole, you would see their clock slow down more and more as they approach the event horizon. For that person, time continues to flow, but from our perspective, it seems to stop. This leads us to wonder, if time is relative, what does this imply for our understanding of the past and the future? Delving deeper into physics, we find the idea that gravity is not just a force that attracts objects, but a curvature of space-time. Just as a bowling ball deforms the trampoline, black holes warp the fabric of the universe. This phenomenon makes us think about how gravity affects everything around us. If black holes are so powerful, what happens to space-time around them? Black holes are not just devourers of matter, they are also emitters of energy. An intriguing concept is Hawking radiation. Have you ever imagined that a black hole could emit light? Stephen Hawking proposed that due to quantum effects, particles can emerge from the vacuum near the event horizon. This means that, although black holes are known for absorbing everything around them, they can also release energy in the form of radiation. What implications would this have for our understanding of energy in the universe? Speaking of energy, quantum physics also plays a crucial role in our understanding of black holes. The duality of particles and waves shows us that, at the most fundamental level, reality is stranger than we could imagine. Particles can behave both as particles and as waves, opening the door to the possibility that information falling into a black hole is not completely lost. This leads us to the famous information paradox. If information is lost in a black hole, does this mean that the universe is a place where nothing is conserved? The interaction between relativity and quantum mechanics is one of the great challenges of modern physics. Current theories still struggle to find a common framework that explains how black holes work at a quantum level. This search for a unified theory invites us to reflect: what other truths about the universe await us to discover? Black holes also make us question the nature of reality itself. If space and time are elastic, are there other phenomena in the universe that blur the line between what we consider real and what is possible? The physics behind black holes takes us on a philosophical journey, where each discovery raises new questions about our existence. Human curiosity drives us to explore and understand the universe. Each discovery brings us one step closer to unraveling the secrets of the cosmos. Through the physics of black holes, we learn not only about these mysterious objects but also about ourselves and our place in the vast universe. In the end, black holes are more than mere astronomical phenomena. They are gateways to understanding the fundamental laws that govern our universe. The quest to understand them pushes us to continue exploring, questioning, and expanding the boundaries of our knowledge. What new realities will we discover along the way? And what lessons will they teach us about the nature of time, space, and existence itself? The physics behind black holes is a reminder of how little we truly know and how vast and mysterious the universe we inhabit is. Black holes are much more than simple astronomical phenomena. They are gateways to profound questions about our universe and our existence. What does the existence of a black hole in the vast cosmos really mean? One could argue that their presence challenges us to reconsider what we know about matter, energy, and time. In this sense, black holes are not only physical entities but also concepts that lead us to reflect on our reality. Whenever we think of a black hole, a question arises: what lies beyond its event horizon? This boundary, which marks the point of no return, invites us to imagine a place where the laws of physics as we know them may not apply. Is it possible that these mysterious objects are a window into unknown dimensions? Perhaps by studying black holes, we are deciphering not only the nature of the universe, but also the nature of existence itself. One of the most intriguing questions that arises is, what does time mean in the context of a black hole? According to general relativity, time is not constant. It distorts under the influence of an intense gravitational field. Near a black hole, time may pass very differently for someone approaching its event horizon compared to someone staying at a safe distance. This leads us to consider the relationship between time and our own perception of life. Are we trapped in a unique timeline, or is there the possibility of multiple temporal realities? Black holes also force us to confront the information paradox. If the matter that falls into a black hole is lost forever, what happens to the information it contained? This question has led to heated debates in the scientific community, where the idea that information can be destroyed with the existence of a black hole is challenged. Reflecting on this may make us question our understanding of information and memory. Is information something that exists eternally, or can it be irreversibly erased? As we explore more about these phenomena, we encounter the idea that black holes could be portals to other universes. The wormhole theory suggests that there may be pathways through black holes that connect different points in space and time. Are we facing the possibility of traveling between dimensions? This idea may seem straight out of a science fiction novel, but it raises fascinating philosophical questions about the nature of reality and our ability to travel not only through space but also through time. The relationship between black holes and vacuum energy is also an interesting field of reflection. Quantum physics suggests that the vacuum is not truly empty, but is filled with potential energy. Could black holes be a means to access this energy in ways we do not yet understand? If we could harness this energy, it could radically change our understanding of technology and space exploration. This leads us to think about how scientific discoveries can influence the future of humanity. The exploration of black holes also invites us to consider our position in the universe. Are we just a tiny dot in a vast sea of stars and black holes, or is there a deeper meaning to our existence? The search for answers to these questions can be both unsettling and fascinating. As we delve into the immensity of the cosmos, we confront the humility of our own existence and the greatness of the unknown. Each discovery about black holes brings us one step closer to understanding the universe we inhabit. They teach us that, although there is much we do not know, each answer opens the door to new questions. This endless cycle of curiosity is what drives scientists and philosophers to continue exploring the nature of reality. Could it be that in this journey of discovery, we are more connected to the cosmos than we believe? Black holes also offer a reflection on the fragility of life. If matter can be absorbed by a black hole, what does that mean for us as human beings? Life is ephemeral, and each day we live is a journey in itself. Just as a black hole devours matter, time inexorably moves forward, taking us toward the unknown. This perspective may make us appreciate even more each moment and each experience we have as the study of black holes advances. It also intertwines with ethical and philosophical questions about the responsibility we have in caring for our planet and our future. If we have the ability to extract energy from these phenomena, are we prepared to handle it responsibly? Science gives us power, but it also presents us with the responsibility to use that power wisely. The relationship between science and ethics is a crucial topic we must explore as we advance in our understanding. At the end of the day, black holes are not just a subject of study for astrophysicists. They are a mirror reflecting our own search for meaning in a vast and mysterious universe. They remind us that, although there is much we do not understand, the simple act of questioning and exploring is what makes us human. The fascination with these phenomena leads us to delve deeper into our innate curiosity and seek answers that, perhaps, we may never fully know. In conclusion, black holes are an invitation to contemplate not only the universe but also our place within it. They push us to reflect on time, information, energy, and existence itself. By exploring these mysteries, we not only advance in science but also come closer to a deeper understanding of ourselves and what it means to be part of such a vast and enigmatic cosmos. So, as we continue to gaze at the night sky, let us remember that each star and each black hole is a part of our collective story, a reminder that curiosity and the pursuit of knowledge are what define us as a species. The universe is a vast and mysterious place, filled with phenomena that leave us in awe. Speaking of the unknown, what makes black holes so fascinating? From their discovery to the latest theories, these enigmatic objects have captured the imagination of scientists and curious minds alike. As we delve into the topic, it is impossible not to wonder, what secrets do they hide within, and what do they tell us about the nature of the universe? The idea of a black hole may seem terrifying, but in reality, they are like sleeping monsters in space that, although invisible, have a profound impact on their surroundings. Their existence challenges our understanding of physics and at the same time offers us a window into what we still do not understand. In this information age, can we really accept that there are things we cannot see or fully comprehend? What is intriguing is that each new revelation about black holes raises more questions. How is it possible for something to be so dense that not even light can escape its pull? This is the essence of their nature. Their gravity is so intense that as we approach, we find ourselves trapped in an inevitable embrace. A phenomenon that challenges our perception of time and space. But what does this mean for us? Does it mean that black holes are the end, or could they be the beginning of something new? Science is constantly advancing, and what was a mystery yesterday can be part of our understanding today. From Einstein's theories to the latest experiments, the quest for knowledge about black holes leads us to explore the limits of physics. What implications do these investigations have for our understanding of the cosmos? And more importantly, what does this mean for the future of humanity? With each discovery, we get a little closer to unraveling the secrets of these cosmic giants. But curiosity does not stop at science. Popular culture has played its part by depicting black holes in movies and books, fueling our imagination. How do these narratives influence our perception of science? Are they merely fantasies, or is there a kernel of truth in them that helps us better understand our place in the universe? The energy that resides in the void, the information paradox, even the possibility of traveling through wormholes. These concepts make us question reality as we know it. What does the existence of a black hole really mean for the future of technology? Could these cosmic phenomena be the key to a new era of space exploration? As we reflect on these questions, it is important to remember that each answer leads us to new questions. Science is a journey, and each discovery invites us to look beyond what we know. In this sense, black holes are more than mere objects in space. They are symbols of humanity's constant quest to understand the unknown. With advancements in technology, missions and telescopes dedicated to studying these phenomena are in full swing. The promise of new discoveries is always present, and human curiosity knows no bounds. What new truths might be revealed in the coming years? The story of black holes is still being written, and with each passing day, we get a little closer to understanding their role in the vast universe. In the end, the fascination with black holes reflects our own search for meaning. We face fundamental questions about existence, time, and space. In this cosmic journey, what do black holes teach us about ourselves? Perhaps in their darkness, we find the light of curiosity and the desire to explore the unknown. The conclusion is that although black holes remain a mystery, their study offers us a unique opportunity to expand our understanding of the universe. Science and philosophy intertwine, challenging us to think beyond the obvious. At the end of the day, isn't that the essence of exploration? As we continue to investigate, let us remember that every step we take toward knowledge is a step toward light in the darkness of the cosmos. So, as we look up at the starry sky, let us not just see points of light, but doors to the unknown. Black holes are reminders that in the vast universe there is always more to discover, and perhaps, in that pursuit, we will find not only answers but also a greater understanding of ourselves and the place we occupy in the cosmos.